Oh, it's not letting me log in. Getting server 500 error. All right, it is 1 o'clock, but I'll give everybody a couple minutes. We should have time. What time is it in Atlanta? Probably super early. 2 a.m. All right. Welcome to the world of international standards. All right, 1 more minute. I'll do it. Do you want to do the intro? Do you want me to do the intro? Do you care?
Go for it.
Okay. Yeah, man. All right, 1 minute after. Let's get this started. There are people that are up. It's 2 a.m. for them, so let's get this show on the road. Welcome to the MLS meeting here. Can we try the clicker? Awesome. Cool. This is the note well. It's Tuesday. This is please read these documents. This covers a lot of good, important information if you're going to participate. Stuff about the standards process, a lot of IPR stuff. If you know something, say something. And it also goes over anti-harassment, code of conduct, copyright policy, and patents and procedures and stuff. You'll see this flashed up at every session. Again, if you're going to participate, you got to adhere to these rules. So thanks. The next one, this is the note really well, which is stuff we want to draw your attention to. Basically, treat everybody with professionalism. Carry yourself well. You don't have to love the idea that a person has, but you should really try to love the person. All right, next, meeting tips. We got the on-site meeting tool. We use this to make sure we get an appropriately sized room. So if you're here, please go to the on-site meeting tool and click the button. That's also the way that we're going to set up the queue so that we can kind of manage both the people here and the people that are remote. So I really appreciate that. Again, you go to the agenda, and you can go down to our session and go pick the on-site tool. All right, so the agenda. Again, we got a scribe. Thank you very much. We're basically going to do things, working group drafts first, and then we're going to jump into the other drafts and things that are candidate for adoptions. So the first thing is architecture draft. So we're going to have Akshaya, I'm sorry, I'm probably butchering your name, talk about mitigations for insider replay attacks. I don't know if you've downloaded the slides. There's a lot of them. I'm hoping that there's some, that's the way to make animations go, but they look really cool, actually. Then we have a status update that I'm going to give about the MLS architecture draft. Then we'll move into the other working groups. Britta Hale, thanks again, Britta, for getting up so early to talk about the combiner draft. And then Rowan is going to have a little bit of a monologue from Rowan here for a little while about the consensus draft, which a bunch of people worked on, that we kind of got decided on a way forward on our last interim, and they've done a lot of work to kind of get that to happen. And then a bunch of non-working group drafts at this point. Some may become the working group drafts, may not. We'll see. So we'll kind of go through those. So Rowan's got a couple. Rich is going to talk about MLS Lite, which we've talked about before. Mark's up to talk about something new for distributed MLS. And Raphael, I assumed it was you that's going to give the presentation for. Oh, he will. Okay, cool. If he's there, great. I don't even know what time it is where he's in. That's got to be brutal. And then we got Grishara. Mr. Grove is going to talk about the nodal E2E definition draft, which has been discussed a little bit on the list. So, all right, with that, let's get ready to do this. I think I'm going to run the slides, and Akshaya, you're going to tell me next slide. So you can come off of mute there.
All right, thank you.
Oh, all right, cool. All the slots, requests of meter already taken. How do I stop sharing? Where's the button? Oh, she's doing all right, great. Well, then all right, I think then all I have to do is stop sharing that. And I think then I share these slides, which are insider attacks. Confirm your selections, and there we go. All right, I think you should be able to progress because I don't have the control. Can you move the slides? Can we double check?
I don't seem to be able to do it.
Okay, you just say next slide and I'll do the next slide. So go ahead.
Hold on, let's try. Oh. Try now.
There we go.
Yep,
All right,
I
I'm
can do
gonna.
it now.
Cool. All right, great, awesome.
All right. Thank you so much. Thank you for approving the slides, even though they seem to have been 125 when I sent it to you. I promise to stay under 15 minutes though. Hello, everyone. I'm Akshaya. I'm a third-year PhD student at Georgia Tech, and I'm excited to talk about insider attacks in MLS today. I'll start with a little bit of background. About MLS and group messaging in general, I guess we can view secure group messaging applications in general as a composition of kind of two building blocks. And the first one is key agreement. This is the primitive that establishes a shared symmetric key among group members in a group chat. In MLS, this is achieved using the tree-cam construction, which gives us forward security and post-compromise security sorts of advanced guarantees. And there's been a bunch of works that study this in isolation and also within the broader MLS protocol. And we're not looking at this part. Instead, we focus on this other building block that we call chat encryption. And maybe before talking about what MLS does for chat encryption, I'd like to ask the question of what do we expect from group messaging applications when we talk about chat encryption? At the very least, we want that our chat encryption protocol guarantees privacy and integrity against an attacker that is outside the group. And we can achieve this using a symmetric encryption scheme that satisfies some notion of authenticated encryption security. However, in group chats, this this doesn't suffice because group members are now able to impersonate each other. They all know the symmetric key. So really, symmetric encryption alone doesn't suffice. But what we need is integrity against attackers that are inside the group and know the symmetric key. So then the guarantees from chat encryption look something like this. Additionally, we want sender authenticity against group insiders. Naturally, we can get this using digital signatures. And it is this that leads to every user also getting their own signing key pair. We look at this building block that we call chat encryption that tries to jointly capture the security of symmetric encryption and digital signatures. We call it symmetric sign encryption in our work. And so just to get a brief overview of how we got here, across two papers, we formalized this primitive that we call symmetric sign encryption, and we came up with security definitions for it in the group messaging setting. Then we looked at a bunch of applications, and for each of these applications, we zoomed in and we looked at what their chat encryption algorithm is, and we tried to cast it down to our model. And then we used our model to check if there were attacks in our model or prove the application secure. In the case that we found attacks, we would then go back and check if the broader protocol sort of mitigated these attacks that we found, or if there's a real world attack against the protocol. And with that, maybe we can move closer to MLS. And a thing I would like to highlight here is when thinking about symmetric sign encryption, it's kind of natural to think about security against outsiders versus insiders. And it is in the latter, in security against insiders, that we find some attacks against MLS. And this is important because MLS in particular considers security against insiders who know AEAD keys and aims to guarantee that even though group members know AEAD keys for all other members, they're not able to forge ciphertexts because they cannot forge the signature. Let us take a quick interlude to look at key derivation in MLS, which I'm sure most of us are familiar with. It uses this big structure where public keys of members are used to derive this secret key. This secret key is used to derive a whole bunch of other keys. And then that key there is used to derive yet again a whole bunch of keys. And finally, down there, we get to derive the encryption keys. I guess the key takeaway here is to know is that each encryption key is uniquely defined by the group you're in, and then where you're in here, which is called the epoch, where you're here, which is called the leaf index, and finally where you are in that chain, which is called the generation. So once again, the key takeaway is that all members in the group know this big giant data structure, and also every encryption key is uniquely identified by this tuple of the group, the epoch, the leaf index, and the generation. And we call this tuple the key identifier. Now let us look at how chat messages are encrypted in MLS. MLS uses a signed and encrypt composition to compose a digital signature scheme with a non-spaced encryption scheme. So first it takes a message and some metadata. So this thing that is signed includes the message body, the associated data, the group, epoch, and the leaf index. And then it's signed using the sender's signing key. Then the message body, along with the signature, is encrypted under an AED encryption scheme using a key that was derived, as we discussed previously, a nonce and some associated data. Now, intuitively, we want that the signature authenticates the key identifier so that an insider cannot re-encrypt a pre-existing signature message pair using a different key and replay this message to the group. If you do, and also just to recall, the key identifier contains the group, the epoch, the leaf index, and the generation. So if we do some kind of pattern matching, we're able to see that the signature authenticates the group, the epoch, the leaf index, but it does not authenticate the generation. And I'll bring up the secret tree again to visualize why that's bad. The lack of authenticating the generation actually allows a group insider to move between generations here in this chain of keys. And that leads us to our first attack, which is the insider replay attack. Let's think about a group message setting where there's this benign looking message. Let's say our honest sender wants to respond with a yes. They would follow the MLS signed and encrypt paradigm to encrypt their message using their signing key and the symmetric key corresponding to some key identifier. And then they broadcast the resulting ciphertext to the group. Okay, group member is decrypted and our client shows them this message. What a malicious insider can do is leverage the fact that the signature does not authenticate the generation. Then they would use this decrypt, then re-encrypt technique to replay messages to the group. So they're going to decrypt the original ciphertext sent by our honest sender. Then they're going to re-encrypt it with a new key. And the only difference between these keys is that their identifiers have different generations on them. In particular, generation 1 is a future generation, that is, it's greater than generation 0. Then they just save this forged ciphertext for later. Once again, they send a more incriminating looking question on the group chat, and now they're just able to send this forged ciphertext to the group. And when group members decrypt it, it seems as though the original sender sent the message once more. So our takeaway here is that not authenticating the generation allows a malicious insider to replay messages sent by honest members by decrypting and re-encrypting previous ciphertexts. This takes us to our second attack, which we call the insider reordering attack. Now, the replay attack was based on the observation that the lack of authenticating the generation allows an insider to move between these generations. This reordering attack is based on the fact that this movement is not really unidirectional. And in particular, generation is used in MLS to convey some sort of ordered information. And if a client receives ciphertext in an order that is different from what the original sender sent it in, then it should still be able to decrypt it in the original order because of the generation. Let's consider this other group message, group chat where there's a benign how are things message. And let's say our honest sender just had a really bad day. They said they had a bad day. Their dog ate their son's birthday cake, and they're going to punish their dog for doing that by giving the dog only dry food. And also, their son forgot to do some things on the list. Now, to send these series of messages to the group, the honest sender is going to sign and encrypt each one of them with sequential keys and send these ciphertexts off to the group. What a malicious insider can do, here each of these keys is indexed by a key identifier which contains a different generation. All right, a malicious insider can block these messages. Then it can launch its decrypt and re-encrypt attack, where the only thing it does is interchange the generations used to encrypt each of those messages. Then it broadcasts these new forged messages to the group. Ultimately, when group members decrypt it, they see something like this, which implicates our honest user for feeding their son dry dog food, which I guess is not as serious as things could be, but this is just an exposition for how things could go bad. But ultimately, the message generation cannot be trusted to convey order information. And with that, I move to the third attack, which is a kind of integrity, which kind of compromises the integrity of ciphertext, but not really the integrity of plain text. And for this, I'm going to recall what chat encryption in MLS looks like. And I'm also going to recall that earlier we said that we want the signature to authenticate the key identifier so that an attacker cannot re-encrypt a message and signature with another key and then send it to the group. For the same reason, we also want the signature to authenticate the nonce so that an attacker cannot just re-encrypt a message and a signature using the same key but a different nonce and then replay it to the group. If you look at the inputs that sign here takes, we notice that the nonce is in fact not authenticated by the signature. Once again, I'll take a brief detour to talk about encryption nonces versus key schedule nonces, and I'm bringing up the secret tree here for that. For every generation, on top of encryption keys, the secret tree also generates what are called the key schedule nonces, but these key schedule nonces aren't directly used for encryption. To generate the encryption nonce N, this key schedule nonce Pn is XORed with a uniformly random 32-bit value. So what we really want is that the signature should either authenticate this encryption nonce N or the key schedule nonce as well as the reuse guard R. And because our signature doesn't authenticate these values, when our honest member sends a message to the group, what a malicious insider can do, here the nonce is defined as the XOR of some key schedule nonce with some reuse guard value. So what our malicious insider can do is block these messages. Then it would do the same decrypt then re-encrypt sort of attack, where now it re-encrypts with the same key but a different nonce, where our new nonce N prime is defined as the XOR of the original key schedule nonce with the new reuse guard R prime. And then it sends out the resulting ciphertext to the group, and group members are unable to detect these forgeries. The value of this attack is unclear because even though the attacker is able to compromise ciphertext integrity, the underlying plaintext remains the same. So the only way an attacker can exploit this is if the application itself uses the ciphertext structure to do anything meaningful, which most reasonable applications would not. And that brings us to the exciting mitigation slides. For each of the attacks that we discussed, there are two kinds of mitigations. There's an MLS level fix, and there's the application level fix. So for the insider replay attack, the attack resulted because the generation wasn't authenticated by the signature. So an easy fix is to just sign the generation. And one way to do it while still being compliant with the current spec is to just include the generation in the associated data, which is already signed. And the same fix also applies for the insider reordering attack. The other fix is the application level fix. And for both these attacks, the application layer fix would be to introduce a unique counter that is included as part of every message that's sent in the chat. And then we sign the message and the counter. Of course, we also assume that the application later uses these counters appropriately to detect replace and reordering. Finally, for the INTC-TXT style attack, the MLS level fix is to either sign the encryption nonce or the key schedule nonce and the reuse guard. And the application layer fix is just to have the application not use the ciphertext bits for anything meaningful. And I think that's all I had to discuss today. Thank you. Thank you for listening.
Wow, thanks a lot. Again, thanks for working through those slides. Any comments, thoughts? Yeah, use that Q button. All right, cool. Rowan's going to get to the microphone in a second.
So I was wondering if, it seems like there might be some privacy implications of signing the generation in the AAD. Just that popped into my head as you did the slide.
I see. That's definitely a thing to think. It's not immediately clear to me what the privacy implications might be. If you don't mind clarifying that, or I'm not sure if there's a back and forth that's allowed here.
Yeah. So I mean, because the generation is per sender, it would give you an idea of whether a particular sender is, whether this is coming, so someone observing the MLS private message going by would be able to tell whether the sender is basically a frequent sender or a not frequent sender based on the generation.
I see. So like members in the group can tell that information?
Actually, in the AAD, because it's AAD, then a non-member would be able to see it as well.
So I think you guys are talking past each other a little bit. So there's the authenticated data field in the message, and then there's the AAD that's fed into the AAD operation. You can feed stuff into the AAD that is not sent in the AAD field on the wire. So I think that we have things that are encrypted as part of the sender data right now that are included as part of the AAD. So you could do the same thing with the generation. So it would be authenticated as part of the authenticated data in the AAD operation, but not revealed on the wire. So you wouldn't have that privacy risk.
Cool. All right. I think we've drained the queue. Thank you very much. And again, thanks for getting up so early. Staying up late, depending on how you look at it. All right, cool. So this is more of a heads up for people. So we have our architecture draft. It is currently in auth 48. For those of you who don't know the process, that is the process right before the thing gets published. And without a doubt, without fail, we got PRs at the last second. So to make sure that those can get incorporated, we have to run through a little bit of process. So that's why I sent the messages, the multiple messages about we have these late stage PRs that came in, and it looks like they're good to be approved. I pinged Ecker to see if he would actually review them as well, but he hasn't had time yet. So it looks like we have support to move these forward. Obviously there could be minor tweaking changes, but essentially the editors are ready to merge them when ready. I will then need to approach the AD to figure out what he wants to do, whether there were enough changes in these things to warrant redoing an entire working group last call on the document and then doing another IETF last call. That's his call, and I'll get to that now. So I'll basically approach Paul and be like, here's what we did. I think we followed enough process. There was no disagreement. The only one that was weird was for PR 274. Theo put in a second revision, and unless people were like, the first one works with these couple of changes, so we're just going to go with that one because it's the one that kind of worked. I'm not sure, does anybody thinks there's, I see any problems with merging these? Because, no, all right, good, going once, going twice. We'll get that to happen. Obviously, there, you know, again, there could be some grammatical changes or whatever, but the gist of these is to go through. Thank you to all of you who reviewed them. I appreciate that. All right, we're done with this. Cool. So I'm done with that. And now it is up for Ron. Nope. Sorry. Yeah. I think that the slide deck is out of order in the thing, and I can fix that later.
Hi, I'm Rowan.
All right. Hold
Next slide, please.
Hold on. We're gonna fix this so you can drive. There we go.
So, yeah, so Richard, I was having some trouble coming up with various things that we were calling extensions and figuring out how to make them work the way that the negotiation mechanism was previously in MLS extensions with the safe extensions framework. Richard came up with an idea, which was basically, there's a bunch of stuff that modifies behavior of MLS, and there's everything else, which is more application specific. So we were abusing extensions. We said extensions when we meant application stuff. We said it when we meant actual extensions. We said it when we meant specifically the 4 core structs, group info, group contexts, key package, and leaf node, and it was kind of a confusing mess. So let's refocus so that an MLS extension generally means something that changes the behavior of MLS. And for application logic, we need to have something else. So we talked about this at a couple of interims. We came up with a plan. He and I wrote a draft, talked about it at the interim. Now we've merged that into MLS extensions. So there is now a safe application API for things that don't modify the behavior of MLS. And as I was going through the draft, like taking things that used MLS, things that were in Mimi, things that were other MLS, previous extensions, and it was just like, this is so much simpler, cleaner, easier to describe, more concise. It just had the feel of something that was right. So briefly, what is that? So for applications, we have this concept of an application component. This accommodates the idea that an application might have multiple parts. So each component has a component ID that's unique within an application. And I use that for domain separation, data separation, label separation, so forth. So previously, there was this extensions ID inside of a safe extensions, but it was sort of conflated with the core structure MLS true extensions. And components also now applies to other things, like if you want to have multiple sources of additional authenticated data, you can dereference them using the component ID. Okay, so if we are exposing different MLS functions to applications, we have a lot of different places we can do that. So we already had, the inside of an application data, we had inside of a private message, we had application data for content. We had authenticated data for AAD. So a lot of the extensions were based on this idea of reusing the ability of MLS to do key agreement on arbitrary data. A lot of were based on being able to store state in the group context. And so we had several different proposals for how to do this. So we ended up with a structure called the app data dictionary. The app data dictionary can be used in any of the 4 core structs. So I can put an app data dictionary inside of a key package, for example, or inside of a group info. And components that are relevant to that particular struct will appear there. Likewise, when I create a group, I can create a group context that has an app data dictionary and has some stuff there. Now, what happens when you want to change that? So I will go through some slides where we talk about all of these, how we do these things. That was a big, we had several different approaches to how to do this, and I think this one really feels right. We also, just like in the previous safe extensions framework, we have a way to do safe labels. The labels now use the component ID instead of the extension ID. The AAD items field in the safe AAD gives you a way to have multiple sources of AAD. And as always, the application data, we had this content advertisement thing that has been, was like my first ever MLS extension. That's now basically a component. Okay, so I talked about the application data dictionary. So this can go in those 4 places that I previously mentioned. In group info, leaf node, and key package, those are basically ephemeral, right? Or like in the case of a key package, it's for the lifetime of a key package. For leaf node, it's for the lifetime of a leaf node. The group info is used once, so it is basically ephemeral. In the group context, it persists in the group context until you change it with a app data update proposal. So this is a proposal which updates specific parts of the app data dictionary in the group context. The format of those updates is entirely up to the app that defines that component. So this could be a blanket replacement. It could be some kind of a diff format. It could be, something else. It could be derived from the, the angle of Venus to, Saturn, right? It doesn't matter. Can be defined by whatever application defines that component. So one point which is important here for MLS stack authors is that this presumes that there is an API where the MLS stack asks the application during the commit process how to apply these updates. Because it needs to know whether the combination that it receives is whether one that it receives is valid in the context of the group context that it previously had, and whether some possible combination of updates is also valid. Okay, a couple of little details about that are important for proposals. Update path is optional for an app data update. An app data update can be an external proposal, not just a member proposal, and it can be included in external commits. All right, finally, we've got, for our second proposal type, we've got the app ephemeral proposal type. This sends a blob of data which is opaque to MLS, but it has, it has component IDs, so you can dereference that. Applications that care about it use it. Everybody incorporates it into the transcript hash. So it can't be dropped, but to the extent that an application wants to do something with this app ephemeral data, it can. And another client that doesn't care, it knows what to do to incorporate it into the transcript hash, and it ignores the rest. Update path is never required for an app ephemeral proposal. It doesn't make sense in external proposals, but it can be in an external commit. One example of where you might use this in an external commit would be if you had a, like say, a join link and you wanted to include it in your in an app ephemeral proposal inside of your external join. Safe AAD follows the same pattern. So instead of having an app data dictionary, it has a AAD items, which has a list of components with their relevant data. Okay, finally, the negotiation was a bit of a mess. There were a few things we're missing. components weren't really, yeah, it wasn't really clear when you were negotiating components how that worked. Now, we added one pair of extensions, of actual real MLS extensions for wire formats, so supported wire formats and required wire formats. We added components for the list of app components that you require or support. We added for Safe AAD components that you would or wouldn't include in Safe AAD, and a content media types component which replaces the previous extensions for supported and required media types. Okay, so somebody might ask, well, how did that affect the previously extensions that were in the MLS extensions draft? We had 5 of them. So AppAC, I'm happy to say, is no longer a standalone proposal. It is now a usage of App Ephemeral. And it was remarkably simple to write. It literally took me 10 minutes to rewrite it to use App Ephemeral. It was quite nice. Targeted message, it's a wire format. It's still an extension. Self-remove is a proposal. It is still an extension. Content advertisement, it is now something that uses a component. And last resort key packages is also implemented as a component. With other than the things that use labels, we have in this
The sound dropped for us.
Hey guys, we're hearing no audio from that room anymore.
Hello, I'm Mujtaba. So I like the whole idea because we're using like heavy use of the extensions now and using them. And I like the idea since it's gonna clean up a lot of our code. And I see a lot of potential that we need to implement manually and abuse again the extension. So yeah, thumbs up.
All right. In terms of other implementers, are you guys happy with this? Do you?
Not to put you on the spot, but
Yes,
awesome. So we'll take
I'm
that.
definitely in support of that.
All right, cool. So we'll take that under advisement. We'll get the working group last call going. That'll actually force people to read it, and we'll see what happens. So expect that to happen, sometime in the next week or two. Hopefully less than that long. So,
Okay.
All right.
Do you guys have a timer thing?
I believe so. Yeah. Well, how much time do you want?
I don't know. Richard, do you still have something you wanted to add, or did you? Okay. Okay. So now we're on to some individual drafts. So because I was already talking, they said, put me first. We talked about getting new Cypher suites for things that use MLChem, both plain MLChem and hybrid MLChem. So specifically, we were like, okay, which combinations of chems do we want? So we want MLChem 768 using a non-NIST traditional chem. We want it using NIST curves chems, because both P256 and P384 are actually in use in the wild. And then in case somebody wanted to be able to use it, particularly to be able to use Britta's draft. By the way, is Britta gonna?
She's next. I
okay.
skipped her by accident.
She mentioned that the speaker mic seems not to be working, but some mics in the room are. So
I can go and grab that mic and bring it up here if you want.
let's try that.
Britta, can you hear me?
Oh, we're having a lot of audio issues online. Just as a heads up.
So you don't think it's a particular microphone, it's just general audio issues?
Whatever mic you're using right now is moderately better, but it is still quite low online. The chair mic does not seem to be working, or is incredibly low.
testing, chair mic.
I'll go with incredibly low.
Testing speaker mic.
That one's much lower.
Testing. Okay, I'm going to put the guest mic back and continue talking with the other one. Okay, so we had these were the combinations that we talked about using. So then we had to turn that into a set of components that we use for actual cipher suites. So, not being a cryptographer, scratched my head a little bit and thought, well, what do we want to do here? So we picked the plain chems were pretty straightforward. Now, there is still the question of what the hash is and what the KDF needs to be. But the signature and the chem for the plain chems was pretty straightforward. In terms of the chem combiner for the NIST curves based traditional hybrids, the obvious choice was what was defined in LAMPS, which is QSF, Quantum Superiority Fighter, I believe is what the combiner is called. LAMPS defines a combination with X25519, which uses the kitchen sink combination. However, the X-Wing combination works perfectly well in the context of MLS, but so in your draft, or the draft that you and Deirdre and friends are in, okay, the chem combiner draft from CFRG, it says that here is QSF with MLChem 768 and P256. Here's QSF with MLChem 1024 and P384. And here's kitchen sink with MLChem 768 and X25519. Now, X-Wing works fine inside of MLS in places that you, like it basically, my understanding is that the kitchen sink takes care of a bunch of use cases that would not be required inside of MLS because of the rest of the special sauce that, you know, the rest of the key management that MLS is providing. So we wrote this here using X-Wing instead of kitchen sink. And I also, you know, I believe that there is not a QSF. QSF is almost X-Wing. There is not a QSF combination with MLChem 768 and X25519. Why don't you go ahead, Mike, and you can get your stuff in the queue later.
Right. Mike Ellsworth. So the LAMP stuff that I'm author of, I would say is all QSF.
Okay.
Not kitchen sink.
Mm-hmm.
Kitchen sink is for handling things that are not MLChem. It's if you wanted to do like RSA Chem, blah, blah. That's it. But the LAMP, the way you've categorized it here, I would say the LAMP stuff is all QSF.
Got it. Okay.
I would just like to up-level a little bit and ask, I think the salient question for adoption working group scoping here is whether this is kind of the right set of combinations here. Looking at.
I mean, really, you mean you're asking this?
Yeah, that one.
Yeah. So basically,
I think that this slide is more important than the following one for the adoption point of view.
yeah. Okay. So do people think this is the right target of, we have a non-NIST thing, we've got NIST things, NIST hybrid things at two security levels, and pure PQ at 2 security levels?
Yeah, I think this is a good starting point at least. I don't have any immediate objections to any of that. The only question is, how long do we want to keep this open? That's hard to say.
Yeah, I mean, I think, personally, I think we want to pull the trigger on this as soon as we have the code points for the HPK stuff that we rely on. And there's more on the 2 slides from now. Mike.
Mike Counselor, the pairings seem reasonable. The way you've presented this slide, that bits column, because we've tried to do the same in other drafts, is how do you represent the overall combined security of a hybrid? Problematic because the post-quantum security is measured in equivalence to AES, and the pre-quantum security is measured in bits, and those things don't merge into a single number nicely. So I have no problem with the combinations you've chosen, but I think the way you presented this table is weird.
Okay, so if we say that the AES equivalent bits of the 2 algorithms together, of the 2 individual algorithms, the traditional and the PQ, correspond to that number?
So where you get into trouble is the AES equivalent bits of P256 is like 3. Like there are like 3 quantum bits of security in P256. It's just
got it.
hard.
Okay. Boss.
Well, it's true that the post-quantum security is 3 bits, but realistically, if we say we want the traditional bits to be 128, like AES 128, then it all works out nicely. Then this matches up. Although I suppose someone from NIST will complain that MLChem 768 actually matches up with AES 192, but we all.
Okay.
Sorry?
The point was that, yeah, we're trying to be like, we're trying to sort of match.
Yes.
We're trying to avoid like low, medium, and high, or medium and high, or whatever. So feel free to send text.
Yeah, like morally, it's like normal level of security, high level of security.
Yeah, exactly. So one thing that in the next table did catch my eye is that you combine the AES 384 and Shake 256 with the basic one with the 768. You don't.
Yeah.
Fine. You don't have to. You could also go for SHA 256 and Shake 128 if you wanted to for the lowest ones.
Okay. Yeah. So I'm going to talk very briefly about the hash. I'm over time. No, I've got a tiny bit of time. For the hash, so somebody pointed out that SHA 256, actually, I've got stuff on the next slide on this. So first question is, SHA 2 or SHA 3? So SHA 3 is already in MLChem. If it was implemented in pure software, then it's easy to go grab the SHA 3 that you have. But if MLChem is implemented in a module or in hardware or something like that, then if we require SHA 3, then you might need to go get a separate SHA 3 software implementation for the hash. Did you want to mention something about that or something else?
SHA 3 is not allowed by CNSA 2.0. If that's a thing you care about, that may matter.
One more time?
SHA 3 is not allowed as a standalone hash function in CNSA 2.0. We just had to downgrade a SHA 3 to a SHA 2 in labs for that reason.
Okay, that's straightforward. Does anyone object to leaving SHA 2 for everything here, and then I'll explain 384 versus 256. Hearing no objection. So somebody pointed out that CSNA like basically asked for SHA 384 or SHA 512 instead of SHA 256. This seems like a pretty easy thing for us to do. So let's just go ahead and use SHA 384, even for things that would have, where SHA 256 previously would have sufficed.
Do you mean SHA 384 or do you mean HMAC SHA 384?
No, we don't need HMAC in MLS in the cipher suites because of the construction. Oh. Okay, then the next question is KDFs. What KDF should we use? I just kind of went, this looks like this is a plausible choice. I don't know what the right answer is. It's 2 hours before the draft deadline. I put it in here as a placeholder. So people can tell us what we think is the right choice. Now, while we're at it, I put a section in the IANA section to register an HPKE KDF for expansion function Shake 256 because there wasn't one. Not knowing that at the same time, more or less simultaneously, Deirdre had written a draft to do exactly the same thing. So that will get pulled out and we'll reference the to be assigned thing in her draft. Okay, so what's the bottom line here? So you guys asked for some cipher suites. We made a best effort to make some reasonable choices, highlighted where we're not sure. I think we closed the SHA 384 thing. We need to figure out what this chem is in the upper left corner, and we need to figure out what the right KDF is. Most of these are going to be sorted out by folks who are in the CFRG, who are working on CFRG chem combiners, and who are in that sort of orbit, the related orbit. I believe strongly that MLS should go ahead and adopt this work, and I'm asking for your support to do that.
Does anybody object? All right, we're going to start looking at doing some more adoption calls.
Okay.
No objections in the chat either.
Yeah. Okay. Here is a nice draft, a zero draft. This is 2 new credential formats for MLS. So for those who are not familiar with selective disclosure web tokens, there are both CBOR web tokens and JSON web tokens. Most people are familiar with JSON web tokens or JOTs. And CBOR web tokens, fewer people in the community generally know about these. They're also called COTs, but one place where these are deployed in the wild in large numbers is WebAuthn. So selective disclosure, it uses a three-party model, so it allows a holder to go get from an issuer a web token, and then blind some of the claims inside it, and safely reveal some of those claims to a verifier. So the holder gets to decide when they take this selective disclosure COT or JOT, and they hand it to a verifier, they get to decide which of the disclosable things they actually disclose. So the holder can disclose all, some, or none of the disclosable claims. The issuer is responsible for saying what claims can be, or are disclosable. And it can also include things called decoys. So if there's some piece of information that, blinding some of these versus, blinding 3 claims versus 7 claims means that you're a US citizen, we can add additional claims. The issuer can add additional claims called decoys to prevent that from being calculated. The SD JOT format includes a regular JOT, 0 or more disclosures, and an optional key binding. I'll show you the format for that shortly. SD COT has a selective disclosure key binding token, or SDKBT, and there's a KBT, and it says in the protected header, this is the key confirmation COT, and then it includes the SD COT inside that, and so everything is all nicely double signed. How the issuer decides which claims to selectively disclose is not in scope. That's up to their relationship. The issuer does not have to make any claims disclosable, but the holder then can say, okay, I'm not going to give this to a verifier if there's something disclosed that it doesn't want to display. Most importantly, both of these include the holder's public key using some kind of confirmation claim, and they can have key binding for proof of possession. Okay, so here's an example of a COT. What can be disclosed? Basically, any of the JOT or COT claims that are not part of the validation of the COT or JOT, except that you can selectively disclose the subject. And then you can do this blinding at many different levels of the hierarchy. So if you've got like 3 or 4 levels, you can redact at different levels. And in fact, okay, so a disclosure is made by taking a per disclosure salt, the value, and if this is something that has a key or an object entry, then you include that as well. And then you go through you take where that was in the document and you replace it with some object with the hash of the disclosure. And so when the payload of that document gets signed by the issuer, a receiver can get a disclosure, it hashes it, finds that hash, goes and finds where it would have lived in the document. It can verify that this was actually signed by the issuer and Bob's your uncle. Let's see. So when you actually do that disclosing to a verifier, there's this key binding. So there's an optional key binding for SD JOT, and there's a mandatory key binding for SD COT. You can also include an audience that's specific to the verifier that wasn't included with the issuer. So in other words, if the audience isn't in the original claim, the issuer may not know which verifier you're using to go and to present this claim to. You can also have a nonce. The key binding prevents copy-paste attacks, replay attacks, etc. It also makes sure that the set of disclosures that you're disclosing don't include any additional disclosures you didn't want to disclose. These can be nested. So in this example, I started off with this complex structure, and I disclose the first level. Then I redact the first level, then the second level, then the third level, and those can all be managed. So how does this work in MLS credentials? It's relatively straightforward. We just need to put the key binding token or the SD COT key binding token or the SD JOT or SD JOT plus KB in the credential field here. In the case of SD JOT, there's a sort of special syntax, which I'll describe in the next slide. One takeaway of this works great with pseudonyms. So if I want to have multiple identities, I can guarantee unlinkability. If I get multiple COTs, multiple JOTs, then I can keep those separate per identity or per public key, so that I can't associate like some member of a group that I'm in over here in my my fetish group doesn't recognize me in my real estate agent group in the community, or my PTA association, my parent teacher association group over here. So if I keep my public keys, use different public keys, I use different identities, I use different COTs and JOTs, those can't be correlated. And I don't need to reveal all the information in them. Okay, SD JOTs use a lot of base 64. So that's an actual SD JOT from the example in their draft. basically there's a bunch of, there's the original jot, which takes up like roughly a little tiny bit more than half of that blob. Then there's a tilde, and then there's a disclosure, another tilde, another disclosure, et cetera, et cetera. And finally, the last thing at the bottom here is a final tilde, and that means it doesn't have a key binding token. If it did, there would be another little base64 blob in there. You know, this works okay, but it's kind of big. And in MLS, if you got big groups, you're going to have big leaf nodes, you're going to have a lot of data. So this has a compacted option. So basically, if you split things out according to the dots and tildes and unbase 64 them, you could stick them in binary here. That's just a kind of a straw person. So finally, in SD-COT, there's a concept of encrypted disclosures. So I could do a per disclosure ephemeral key and encrypt it with AED. In the MLS context, this allows a disclosure to be hidden from the DS and shared with all the members, or even with targeted message with a subset of the members. So that's it.
All right, cool. So this is a 0-0 draft. So I think we should take most of the discussion of this to the list to make sure that we can stay on time for all the rest of the presentation. So feel free to grab Rowan in the hall if you are here to talk about this. Thank you. All right, Britta, you're up next.
All right, there are no slides for this one.
Oh, okay, good.
I wonder if you're missing something there. So this is about the hybrid combiner draft. It was briefed last time. We had a call for adoption, and it was adopted by the working group. So this puts two different combiner versions for MLS. So the version that Rowan just briefed, where you have hybrid cyber suite, and every update is for the hybrid. And if you have a good connection, that's probably the easiest to implement. The hybrid combiners draft is more of an amortization approach. So it separates out two sessions, one for your standard and one for your post-quantum, and spreads the cost of those post-quantum updates over time. So this is, again, adopted already by the working group, and we had a takeaway to make some expanded scenarios in the security consideration section, where we look at different settings or profiles, you could say, for when you update which one and what that means in practice. We have recently pushed out a working group draft version, so that there's a copy of that out now. And that does not contain all those promised updates because we pushed out the wrong version. So more updates will be coming to a Git repo near you very soon. But this is an excellent time to go and read that draft if you have not already. So we think it's pretty straightforward. We'd like to do a last call soon. So if you read it and have any inputs, please put them on the mailing list, and we will try to adjudicate and include those as we do this next revision, and then be able to move forward with that. And
Awesome.
that's all on that one.
Awesome, thanks. Yeah, all you smart people that I saw at the CFRG, read this document. All right, so next, Richard, you're up. All right, I'll give the bot sticky thingy this thing, and then you can.
Yeah, in addition to CFRG, you may have recognized Britta's stuff from PQIP yesterday as well. So
yeah,
you were there for that. You should take a look at her draft. All right, light clients, completely different. This is about making MLS work better in practice for large groups. So this has been a draft that's been around for the last couple of cycles. This is, you've probably seen most of this content if you've been paying attention in the last couple of cycles. So just to fast forward, like, think about whether we should adopt this, because that's what's coming at the end. But just to refresh people, when you're operating MLS, the thing that stays big, even despite all the optimizations you do, is that everyone who joins needs to download credentials for everyone in the group. They need to download the ratchet tree and verify all the hashes and all of that. So that can get big if you're talking 1,000 participant WebEx meetings, which we do support. This is order of megabytes, which is not all that intimidating to those of us who live in the modern world. But out at P99 and those farther percentiles can be bad enough that, like, product managers notice and complain, and you get customer complaints. And so, because in particular, because before you download the tree, you don't have the keys for the meeting, and so you're sitting there looking at a blank screen. in this sort of real-time application. So it's like not a great application experience, where it's one of those cases where protocol deficiencies translate very directly into user pain. So like that's what we're trying to fix. The solution we are proposing here is to have what we call light clients. And basically this amounts to being able to join and get the confidentiality keys before you get all the authentication information, so that you can kind of lazy load or stream in authentication information as you go. So if you're a light client, you join immediately, you don't get the ratchet tree because that's the slow thing. You're in a limited state where you can't commit and you can't process a normal commit without some help, some additional data tagged onto it. And so while you're in this light state, it's nice because you can go fast. You only have a little bit of information to maintain. And you rely on the DS, you basically outsource to the DS, so it's, provide you with the extra information you need to keep up with the commits that are coming in. But the upshot is like, while you can join very quickly and stay joined with very little resource utilization. How do we do this? We basically, like I said, outsource some stuff to the DS. So in a group where you have a mixture of regular and light clients, basically the regular clients will participate as normal, and then the light clients will get commits and welcomes that have annotations. So they won't get the full tree, but the DS will annotate the welcome or the commit with just the slice of the tree that the client needs. By slice of the tree, I mean basically, if you put your head in Merkle tree land and you think about a membership proof in a Merkle tree, it's basically the same thing, but following a slightly more complicated hashing structure that MLS has in its tree. So basically, when you send the welcome, you send a proof to the new joiner that they are in the groups. They know that they're not being added to some nonsense group, and that whoever is welcoming them to the group is also in the group, so that they know it's all coherent. And each of those, as you can see, is kind of follow this structure. They have log depth because it's just like a Merkle tree membership proof. So this is what I mean when I talk about the annotations. This is similar stuff when you get a commit, so that you know just enough information about the tree to authenticate the sender. You can also apply this to messages, right? Because messages has a signature. You need that leaf in the tree to validate the signature, and so you can annotate a message that's encrypted with the private message structure, so that a light client who doesn't have the full tree can authenticate that particular message. These limited bits of authentication will become important when we talk about trade-offs later. Yeah, Rowan.
Yeah. In the implementation that you tested, was the fact that you needed the group context as well to validate the authentication, was that problematic, or was that just sort of the group context other than the ratchet tree was sort of nominal and size?
Oh yeah, the group context is tiny. It's like a couple hundred bytes.
In that application.
Yeah, in the application we've got, where we're not leveraging any of those nice application. Yeah, exactly. We're not sticking a whole bunch of stuff in the extensions field. Yeah, of course you can shoot yourself in the foot that way, or create difficulties for yourself that way. But we're not right now, and yeah, this is not attacking that problem. This is just more information about the structure of those messages. If you like reading TLS syntax, you can look at it in the draft. But it's basically what I said. You tag the welcome and the commit with a little extra data. It's just enough of the tree to get what you want at the given time. There's another draft that I'll mention here called split commits, which addresses another scalability problem. So another thing that remains large in MLS is commits. So a commit message encrypts, has all of the encrypted entropy to every member of the group at the same time, and signs that whole thing. So each member has to download everybody's ciphertext, even though each member is only going to use one of those ciphertexts. So Marta and Joel have the split commit draft, which rearranges how commits are signed so that you only have to download the one ciphertext you need. So you get, and I think there's some log number of public keys or something, so it's not constant, it's log scale. But split commits take commits and make them log scale. And what's nice is that these things compose together. So if you're doing these light commit, if you're doing light MLS, you can join in login resources, and you can keep up in login resources. But when you process a commit, you need to process the whole big commit, and have linear scale resources to process that. Split commits kind of do the opposite. They don't speed up the join, but they make commits fast. And so if you do both of these, you can get to a situation where someone who doesn't care about authenticating the whole membership of the group can exist and participate in the group with only log scale resources. You only ever download log information, you only keep log scale information, which is really nice when you talk about really big stuff, broadcast groups, IoT management sort of scenarios. You can get really good performance at the expense of some authentication guarantees. Which brings me to authentication guarantees. This is kind of the big trade-off, and the thing that I think in the prior discussions of this, people got a little wary of. So I just want to flag this up and say, like, there is some discussion in the draft, and we have some validation of this. So as I kind of hinted up front, we're trading off authentication for confidentiality. You get confidentiality immediately, much faster, at the expense of not getting authentication data right away. So you are, the light clients who are in that light state are in this kind of intermediate state where you can do encryption, but you don't know who's receiving the encrypted data if you send something. You can verify the identity of things you're receiving. You can verify senders' identities using this, these little slices of the tree, but you don't get the knowledge of the whole universe of receivers. And what I'd like to point out here is, like, there's several use cases where, from an application point of view, this looks acceptable. I realize this kind of, always trading off security properties seems kind of scary from an in-purposeful design point of view, but there are application scenarios that this maps to plausible outcomes. So, I mean, if you think about your experience with something like WebEx or Zoom, like when you join a meeting that has 100 people or 1,000 people, you're not seeing all of those identities anyway. You have limited visibility into the authentication state of the meeting anyway. And so it kind of makes sense to stream some of that in, say, as you scroll through the participant lists. And for these like broadcast cases where you're maybe sending out commands to an IoT network or whatever, the receivers of those things really care about the source of the data being authentic and the data being confidential to whatever group this is, but they don't care about the identities of all the other participants. So they don't actually need the rest of the tree to understand that there. So the broadcaster, the sender, who is the full kind of owner of the group and has a lot more resources, they can keep track of the whole tree. And the folks who don't care about all that information can exist in a much more light state. So what I'd like to make the case is, like, yes, there are some trade-offs. We have got appropriate caveats, or we can write appropriate caveats. We should make sure of that through the working group process. And we've got some formal analysis that verifies that the amended authentication properties do in fact hold. So so last status here, last slide. Like I said, we've actually presented this last 2 IETFs. So it's been hanging around for a while. I haven't kind of tried to drive it to conclusion yet. So I am now asking for adoption. Finally, now we should do this, because I think it's actually pretty mature. So I worked with the Crispin folks, Franciscus Kiefer, Karthik Bhargavan, to do the formal analysis actually before we even submitted it to the IETF. And in fact, that analysis covers both the light MLS ideas and the split commit ideas. So we have some updated security definitions to cover the different authentication state and proofs that those hold in the revised protocol. We've had this in MLSPP, one of our, the library we're using for WebEx, and I believe Discord is using as well. So it's been in the code. We've had it, and we're building it out. We haven't shipped it yet, but we are interested in doing it. I talked with Discord some, and they're interested in this as well. And so it seemed about the right time to start asking the working group, should we adopt this and maybe make it an RFC? And I think the question I would ask as well, hopefully folks may have taken a look at the Malarchik draft, should we combine this with split commit, even though they're kind of orthogonal, they're addressing different parts of the process, they're optimizing different parts of the process. But if you combine them, if you do them both, you get a very nice combined property. So should we combine those drafts together? So with that, I'll throw it open to the floor. Thanks.
All right, we got 5 minutes scheduled for this and 4 people in the queue. I'm going to lock it now.
All right, yeah. I'm going to go back to what I said last time at the last IETF in Dublin. So for context, I think this is really valid. There are many implementers who need that. It's something we've been discussing for a while. Generally, we discussed double joining, etc. back in the days. Fundamentally, you always have to go for some sort of compromise. In this case, it's very clear authentication is what's being compromised here. So for me, the risk remains that, you know, people will perceive this as a variant of MLS. And this is what I think is problematic in that context. For me, this clearly falls into the category not of state-of-the-art end-to-end encryption, but in the category of opportunistic encryption. It's more nuanced, obviously, and you just discussed that, but so I would really like to raise that again, that I find it problematic that this, you know, is being proposed as a variant of MLS in that sense, because in a way, you know, it's been a few years now. MLS has been covered by a lot of academic research. It's holding up pretty well. It's become almost a bit of a brand in that sense. It's going to be rolled out worldwide with Google and Apple hopefully soon. So I see that risk, and I'm sort of afraid that we could sort of taint the real security we have with vanilla MLS in the perception with that. So yeah.
Yeah, I'm happy to put whatever warning labels make sense on this. Yeah.
And as for split commits, I think they're not problematic. I think we should adopt them probably separately, simply because they might also make sense in a different context. Then we don't have that tied together.
All right, Britta, you're up.
So echoing similar concerns on security here, this is a rather huge trade-off. Obviously, entity authentication directly has effects on the confidentiality and data authentication, because if you don't know who you're talking to, you have no idea how confidential that is, and it's all being punted to the group owner. Now, I'm not going to debate like the use cases. I understand that you have the use case for this, and there's other environmental controls that make it maybe uniquely useful. But I'm very concerned about the security statements in the draft and the naming of the draft. So I looked through it again, and usually those security statements, even at the start, it's very lightly touched upon as minor authentication trade-offs, or at least that's how the perception is. And this is actually quite major. And to Raphael's point, if this becomes mixed with our normal interpretation of MLS, then now it will sound like MLS itself is not secure. So I think, one, there needs to be very clear and much clearer warning labels included, but also to the point that was discussed heavily last time, the naming should not be quite so enthusiastic, like this is a better version of MLS. And I know the authors promised to look at that again. I think that term that Raphael just mentioned, opportunistic, could be something to be looking at versus just a lightweight version of MLS. This isn't just a lighter weight, it's actually a different approach here. And we need to be very careful with the warning labels so that when people look at it, they understand what type of use case environment they need to check for in order to say, yes, this is okay in that environment versus just okay generally.
Rowan May. So I think we need to do both of these. I want to keep the two documents separate. I have an immediate, you know, the split commit stuff I think is immediately useful, and I think it would go very nicely with some experimental work that I've been looking at update path proofs, which also would solve a bunch of other things. And so, yeah. I have a proposal for a name. Partial MLS. I think that gives the right semantics. For the people who are particularly concerned, does that feel better?
I was thinking just like a skull and crossbones emoji, but maybe we can put that at the end of.
Yeah, Mushtaba Chanani. So I'm coming from somewhere that we need this urgent, and I vote for it, both split commit and light MLS. I'm okay with the light MLS. It's like self-explanatory. It's obvious. Plus, we already, as you and WebEx started using it, we already started like adopting such ideas and implementing it. So I would say the name is obvious and it's not hurting MLS itself. So you need it, you use that part of it, you can enable, disable it. But I mean, we need such a thing for like large groups, like with thousands of people, and we will have like a couple of senders. So it would be easier to authenticate those senders because most of the people there are just like audience to read the messages, not send anything. So it would be easier to authenticate those like limited senders in the group. Thank you.
All right, so I heard make sure that you don't combine them.
Yep.
And we can discuss the name of the coin toss and
Yeah,
the correct emoji and all that stuff, but we'll run an adoption call and see what people think.
Okay.
Because I mean, again, this gets down to like how long you polish the draft before you decide to adopt it or not. We've been talking about this for like a year. It's time to pull the trigger.
Oh yeah, and then like I'm not faulting the group for that. I've been driving for it. So, but yeah, I think it is pretty done. And like we probably do just a couple spins of this and send it to the last call. Thanks.
All right, cool. Mark, you're up. I'm giving you control.
Thanks. Hey, folks. So I'm here to talk about distributed MLS, which is an approach that Joe, Britta, and I have been.
Can you get a little closer to your mic or turn the gain up a little bit?
Let me try that again. How about now?
That's a little better.
Okay. So hey, folks. I'm here to talk about distributed MLS, which is an approach that Joe, Britta, and I have been working on. Let me work this slide. How do I work the slides? Ah, there it is.
There we go. You got it.
Thank you. So the problem set, as a baseline, MLS, if you get a set of participants to agree on the commit on a commit order, MLS is a really powerful primitive for deriving shared cryptographic state over time through PCS updates. That's the core promise of MLS. And the architecture doc gives some guidance on how to achieve that agreement. But nonetheless, coming to this, the three of us coming to this from very disparate problems where that's still a rather tough goal. For illustration, we work on a consumer messaging app that is built with distributed architecture in mind. So we're reasoning about local state on users' devices. Joe, if you want to talk about your problem set.
Sure. Just very briefly, yeah, I'm coming from a space of looking at coordination among unmanned systems, groups of unmanned systems. So similar issue here.
And Mark, it is a little bit quiet still on your side, so if you can project or speak louder, maybe that'll help.
Okay, I will try. I will try so. So we're coming from disparate problem sets. Approaching thinking about local state and what can we do with MLS to get the properties that we would want from group messaging, from secure messaging, and what we arrived at is distributed MLS. We don't reach group consensus, but we can still get evolving cryptographic state through PCS updates. And so let's sketch out the problem setup for a universe of participants defined by the application. Each participant operates their own MLS group as a send group that allows them to locally control the evolution of the group. They can use the send group to encrypt application messages to the other participants in the universe in a context where the sender controls the recipient set because they're locally controlling the evolution of the group. And lastly, we've devised a scheme where you can import PCS across groups with the use of export pre-shared keys. So the primitive here is a sender group, which is an MLS group operating in a constrained mode. So the sender is the MLS group creator at the 0th leaf index, and other members only accept messages from the owner. So for example, Alice has a group, Alice sends in that group to Bob and Charlie, and they're in receive only mode. Bob and Charlie each operate a group of their own. So the question arises, well, Alice can send PCS updates to the group. How do we do PCS updates across relative to each of the members? And in distributed MLS, we can do that with the use of exporter PSKs. And so you start off with, in the group that you control, in your send group, you can introduce PCS with a commit, where you have a non-empty path. And then following that commit, you can export, members who have received that commit can export a pre-shared key and import it across groups under this scheme here, where you're identifying the pre-shared key by the epoch and the group ID of the originating group, and exporting a key with a label and context. And so it is an illustration of how this would work. Alice is sending messages in her group in epoch M, wants to introduce PCS into the universe, and so sends a commit with a non-empty path, updating her leaf node, and starting epoch M+1 in her group. And on receipt of that commit, Bob and Charlie can then propose in their group a PSK proposal incorporating a PSK exported from the M+1 epoch of Alice's group. And on the incorporation, on committing that PSK proposal, they've now incorporated the PCS that Alice introduced with that initial commit. And so that's the sketch of where our current proposal is: a center group mode operation of MLS groups, and a mechanism to introduce PCS in your own group and incorporate them across groups with an exporter PSK. We're still interested working on how to update credentials in an efficient way across these groups, and that's something that's still an open item of work. And so I'm curious to hear from others if this is of interest, feedback, if there are other problem sets this might be relevant to.
All righty, the queue is open. Richard.
So, Mark, thanks for presenting this. I think this is really interesting work, and I think it's a good sign that we're seeing MLS. Folks figuring out how to use MLS in more environments that may need to address the design constraints of MLS a little differently. I think this is maybe not quite ready for adoption at the moment. Might just need a little bit more maturity, but I like where this is going, and I like that it gives a little more flexibility and more adaptability to the protocol.
Yeah, I mean, the draft was posted like this week, so yeah.
Yeah, what Sean said.
You got to start somewhere.
Yeah, so Rowan May. So I think this is interesting. I'd like to explore some use cases in the draft where it's not just one person, but it could be like a cluster of, it could be a group that is expected to stay together. So it could be everything in a vehicle, or for example, and then the other groups could represent other vehicles, for example. I'm curious if you have an opinion about that. If you think the mechanism there would work in that environment where maybe some of the individual clients in that group are not all available at the same time, but that they have they don't need eventual consistency among them in the same in the sender group.
I'll just weigh in on that question as one of the co-authors on this one. So I think that actually is an interesting composition with the draft that Conrad Coburg has up as well on the subtrees. So if you have these sort of subtrees are the single senders per their group, then you can have the others are listening. And so in your case, then all the devices at one vehicle could be sending information, whereas others are receivers only. So yeah, definitely the nice part about this is that it helps to deconflict potential update collisions if you are not relying on a central server to do that for you.
So actually, it seems like one of the interesting questions about this is how well the security definitions that we have for regular MLS map to this more loosely coupled case. Has any thought been given so far to kind of how to adapt those definitions and whether and how to develop proofs that the kind of compound of all these coupled groups satisfies an overall security definition?
Sure. Yes, there has been some thought to that. And I don't mean to jump in, Mark, please weigh in here. But the interesting things are that really the sender gets control. So the sender, the owner of any one of these groups, has control about when updates are incorporated. So as far as PCS and FS and all of that, in many ways, it's very equivalent, but who has the right to decide of when that process changes? On the flip side, the interesting thing is that no one of these groups gets held back by the other. So you get some both interesting gains and slight differences where there's no like better or worse scenario. So that's still to be fleshed out in more detail in the draft. We have some mention and discussion on there lightly, but it's just a slight difference about who gets to decide when these are processed. So the sender naturally is the one most impacted. If you're a receiver, you're only receiving the information, but the sender is most impacted. So there's also an incentive for them to input and apply the commits and all that as quickly as possible. So the core security approach in some ways almost goes up in that respect. But yeah, there's a fundamental slight change there.
All right, cool. We drained the queue. I think what I heard was keep working on it, and people are going to jump in and take a review and provide some input, Rowan and Richard included. So that's awesome. All right. Thank you very much, Mark. Thanks for probably getting up pretty early or staying up late. All right, now we're on to Conrad. Let me go do this. Decentralize. There we go. And I will give you, where are you in this list? I'll give you control. All right, go ahead.
Hello. Is audio okay?
Yep.
Okay. So yeah, we took a look at the same problem, but from a different took a different approach to the solution. We also ended up with something called DMLS though, so there's something to that. So our approach is looking a bit more under the hood of MLS as opposed to using MLS to kind of as a whole to make it work. And just as an example, if in MLS we typically have this nice chain of epochs, and I labeled them days here in the assumption that we have one epoch per day, where you go from one epoch to the next, and the delivery service makes sure there's one commit that ends one epoch and introduces the next epoch. However, in some scenarios, you can have, for example, a net split, and I'm going to use this example throughout the presentation, where you have, say, you have a federated scenario, and you have two servers that share the role of a DS and manage the commit order. But now there's a connection interruption between the servers, and one half of the group is stuck on one server, and the other one is on the other, and they both want to continue using the group. And so we start with day 0, and then on the left side, the one half of the group is busily going ahead and sending commits and evolving the group potentially and sending messages. And on the other side, it's the other half of the group that's also just using the group, maybe even just oblivious of the net split happening. So what happens when the net split stops and we want the groups to be able to consolidate, i.e. be able to process all the messages that were sent on the other half of the net split? What we have to do is we have to keep old group state around so that they can still process these old commits from day 0. And that's not great, because keeping old group state around implies keeping old key material around, and I think we all know that's not great for forward secrecy. And so even if let's say I was on the right part of the net split here, and I've kind of dutifully deleted all the group states on day 1, day 2, day 3, up to day 5, which is my current group state, then because I had to keep around the key material of day 0 to be able to process the old messages that I've missed, or sorry, not the old messages, the messages that I didn't get from the left half of the net split, the adversary can still use that if I'm compromised. Oh, there's I think I inserted the slide at the wrong place. Yeah. Sorry, ignore the previous slide. I'll get to that in a second. The adversary can still use that to reconstruct all the key material from day 1, day 2, day 3, day 4, etc. And so thus effectively destroying my forward secrecy. But academia to the rescue. There's a great paper by Joel Alwyn, Marta Malarczyk, and Yanis Telekunes that introduced fork resilient continuous group key agreement, and they also include a construction that essentially modifies MLS, or a variant of MLS, strictly speaking, so that we get better forward secrecy in these cases. I just want to quickly see how that works, where we have this, and this allows us to keep old group state around, for example, this one on day 0, and then delete this specific key material that we need to transition from day 0 to the one here on day 1 on the right side, so that this is actually forward secure again, and still allows us to compute all the messages from the other half of the net split that we couldn't process earlier, or yeah. And so pretty much the most invasive change that we have to MLS to make this possible is that we change the way that we compute the init secrets. So the init secrets is the key material that goes from one epoch, and that's used to initialize the next epoch, essentially. And what we're doing is we're using a punctual PRF, a PPRF, to derive these init secrets now, so that we don't just derive one init secret as we do when we have this kind of linear chain of epochs, but instead we can derive multiple init secrets to derive kind of multiple potential next epochs that we can get. And so if you look at this as kind of an excerpt from the MLS key schedule, where we have at the top, we have the epoch secret, and that's deleted. And from after we've derived the other secrets, like the Explorer secret and the encryption secret and all the other secrets that we have. And that's also used to then derive the init secret. And in this case, we use it to derive the parent init secret. Sorry, there's a typo there. Before we then delete the epoch secret. And then we can use the parent init secret to derive multiple child init secrets, where if we derive a child init secret, we can modify the parent init secret, we can puncture it so that you cannot derive the child init secret 0 in this case, again, if the party were compromised. Okay, so there's this modification is kind of under the hood. This is definitely an extension that modifies MLS, but there's not that much more to it to actually enable this gain in forward secrecy. The complexity in this endeavor that we're trying to do here comes from then also merging, kind of processing all the commits from the other fork, and then kind of arriving at an end state and then trying to merge that end state again so that we have one group that everyone has the same view again. So we get the nice agreement that we get from MLS. And so, yeah, we're still at a point where we've just written down the draft, again, based on fork resilient continuous group key agreement by Alwyn et al. And to be able to process multiple commits per epoch with better forward secrecy. But we haven't really worked out a good way to actually merge the state of the different forks once you arrive in them. And we are kind of tried to do this because, well, in the architecture document, we have this eventual consistency versus what was the other one? Immediate consistency, can't recall. Anyway, there's no good way yet, and I think that's also motivated the Mark's presentation, to actually have a kind of a client-based DS design. And with this, we're trying to get closer to that idea that the clients actually take care of that. And yeah, so again, we're trying to implement or specify the work based, the fork resilient concurrency GKA work by Alban et al., and are still working on the fork consolidation, state consolidation part of the protocol there. So yeah, just wanted to give the group a heads up that we work on this, and we'll keep you posted on changes. Currently, this is all still quite some work in progress. Although the spec part, so how MLS has changed, I don't expect that to change a lot. Any questions?
All right, going once.
Okay.
Thank you. All right, I guess we'll just keep talking about it on the list and see if we can get some interest going. Okay. All right, cool. So the last presentation of the day, I'll stop this timer, is, I assume Mallory's going to do it, though I see Olaf here too. So Mallory, go ahead. I haven't seen slides from you, so I assume you're just going to talk.
Can you hear me okay?
Yes.
Okay, my headphones are not attaching properly. I apologize if audio changes somewhere in the middle. I also see my co-author Olaf, you're here as well.
He's in the
Sorry,
back.
everybody, it's early in the morning, and yeah, we don't have slides, but really, really appreciate time on the agenda for this very recently introduced draft to the group. It's not, however, a new draft. So this is, if you folks have been participating on the list, it's draft-nodal-E2EE-definition. The draft has been around now for a couple of years. The motivation behind it was, at the time, I think very well supported by several folks who gave early reviews, including Britta. We got feedback from several folks actually in the room right now. The original motivation was there doesn't seem to be across the IETF a solid definition of this. Of end-to-end encryption, end-to-end encrypted messaging, I think, is where we've landed on it. So that's been one suggested change in the past to change the scope of it. But in general, we define end-to-end encryption in a few ways in the draft. So the first is sort of just a direct definition of encryption, what end-to-end encryption then means, and then that in context. The second way we sort of look at defining it, because that's sort of an incomplete and unsatisfying approach. The second way is more looking at lists of requirements. So it's really common to think about what are the authentication, integrity, and confidentiality requirements, as well as some of the key features. So some discussion of this draft in the past. That mostly has happened in the security area, but then this draft has its own email list, has been around what to include as absolutely core features and functionalities rather than sort of good to haves or add-ons. Deniability, for example, would be one that maybe doesn't feature as a core. And then I think that's the major tour, right? We also then go through, I think, some really critical challenges and gaps, things that we know are issues, things that in encrypted messaging, will continuously fall short. One very obvious example is, metadata. This is a known problem. It's something that needs to be minimized. Implementations will do that differently, but it's useful to name that and to discuss, what sort of is the best practice around that. what else do I want to say about the draft? I mean, I think we can pick up where the list discussion has left off, because I want to appreciate Brendan and Britta, who've both come in on this question of whether or not key transparency or other state-of-the-art techniques actually meet the high bar definition that we have in the draft, and how might the text properly relax that to accommodate that. And I, if I remember right, those suggestions on the list, I think are great, and we should do them. I'm going to stop there. I don't know if that was enough of an overview. I don't want to spend too much time on this, but I'd be really happy for folks to come on the mic and talk about it. I guess maybe just before I end, because the draft has been around for a while, I guess I should say why we came to MLS. So I think the thinking is that if this were to continue in the general security area, it actually probably does fit best in here. I know all of the presentations today have been very specific to the MLS protocol. I think one tie-in, other than the fact that it's obviously encrypted messaging, is that the GSMA spec that folks have mentioned does actually cite this document, but it doesn't cite this internet draft. It cites an IACR preprint of this draft. And the authors of that spec found it useful to have a definition. And so I think, and that's the GSMA spec is the RCS that over MLS over RCS specification. Anyway, so it would be great if I think we could all come to consensus on a really solid version of this document. That would be a really great goal to have. So I appreciate all of your feedback, and whether or not this draft becomes is adopted in this group. I think just the reviews and the discussion already have been great. So thank you, everybody.
All right, thanks. I haven't done the show of hands tool yet, so I want to try that. I want to know who's read the draft, because that's usually yeah. Yeah. That's actually a pretty good number, actually. All right. Just out of curiosity. All right, 13-3. Okay, so this is kind of, the draft has been around for a while. There hasn't been much discussion on the list, so I'm hoping to see a little bit more on the list before we go and kind of do an adoption call. I like the idea that there's a need for it, but I do think we need a little bit of talk about it. But David, I see that got people to get in line, so.
David Skenazy, Internet Architecture Board member. I'm very confused as to why this draft is an MLS. The charter doesn't seem to cover issues of global internet architecture. That's kind of something that we do in IAB documents. And I'm not saying that as, oh, that's our lane, but why would it make more sense in MLS than in TLS? There's end-to-end over there. It's kind of a different thing, and that's a whole part of the problem. But it seems very surprising that this is here. Kind of the history of the draft, the reason that it's still a draft is a little complicated, but it was kind of discussed in the IAB, it was discussed in SAG, which were reasonable venues for it, because it's more of a generic thing that's not specific to MLS. So obviously, I'm not seeing the AD in the room, and they would be the authority on the charter, but this seems very odd, because even if people have read it, this might not be the right place.
Felix?
Yeah, hi. I've read the draft too. Maybe a similar comment to David's. When I read the draft, I wonder what the overall intent of it is. And Mallory, I would be curious to hear your comments on that. You said a little bit about it in the beginning, but what problem is the draft trying to solve?
Mallory? Uh-oh. Might be having some connection problems. All right, let's, oh, she's back.
Are you able to hear me now? I'm really,
Yes.
so yeah, really sorry. I wanted to respond to both. We did talk to Paul about this extensively, the area director, about where this should go. I was surprised at his response saying that it should be an MLS. So I definitely went with his advice. We talked about it. We talked about it with Sean and Nick, asking the question, like, is this in the charter? Do we see this document in the charter? And the answer was yes. Actually, it looks like it fits. I think somebody else came in on that question as well. So yeah, I appreciate it doesn't fit really easily anywhere, and that's one of those things. What's the motivation? The motivation is, it feels like it may be less now, but maybe, well, just as much now. There's folks who want to extend kind of this definition of what would be acceptable as end-to-end encryption that goes beyond what I think a lot of us would find acceptable. So for example, there was this proposal to I think of it as sort of proliferating metadata, like expanding the use of metadata to be able to track messages. So yes, you're not looking at message content, but if you sort of trace where messages have gone through, one platform, for example, you could, maybe that's useful information, and it doesn't actually break encryption. But I think that goes counter to the sort of direction of travel of the problems we're actually actively trying to solve in encryption, which is to reduce metadata. Like, that's one very small example. But I guess like there seemed to be at the time, and I think there still persists, this need to establish what is in scope for an application that is trying to ensure end-to-end encryption is not just present as a feature, but it's a whole system. And it's a whole, it's got its own set of design requirements, and elaborating those is helpful so that other requirements that are not within that list are therefore, and maybe in paradox with, working cross purposes to that list, then exist elsewhere. Like, this is not an end-to-end encrypted messaging application. That's another kind of application. That was originally the motivation. I don't think I'm articulating it as well as I would have at the time, but I think we're still holding on to this idea that would be useful in that way.
Okay, yeah, if I understand you correctly, you're saying a couple of maybe systems start going in directions that we would not consider end-to-end encrypted anymore. And I think I have an intuition for what kind of developments you might be referring to there. But I wonder whether a draft defining end-to-end encryption would solve that, right? But because these people, they do that because they have an underlying motivation, or these organizations, right? And then if you say, well, that's not end-to-end encrypted anymore, I would just think they shrug and say, well, then it's not. Like, we still want to track the metadata, right? But
No, of course, yeah.
Yeah. But okay, thanks for answering the question.
Yeah, can I just maybe offer another? I think it's not only that there are those motivated to try to describe systems that are end-to-end encrypted with features that we would find objectionable. I think also the platforms themselves have some sort of, I don't know, equities at play, that where there's some temptation, for example, to use AI. This is a sort of more recent development, but I've also put out a paper not cited in this or necessarily directly related, where there's a lot of hope that maybe there's some new features like AI enhanced features and so on that are very data heavy, obviously. How do you use those features in a place where you are by definition restricting access to data? What are the boundaries for that? So I don't think it's always an external pressure. I think there's increasingly internal pressures as well for access to this data. And maybe it's not the specific content all the time. It could be a derivative of the content, could be the metadata as well. But I think it's useful to try to define what are the best practices and the tightest possible way of defining what we're actually trying to do with end-to-end encryption.
And before we get to the next question, I'd like to just make a comment about the charter. Currently, the charter is focused on extensions, MLS protocol extensions. And we invited Mallory here to explain her draft, to bring it to the working group members to see if there's interest in adopting this or potentially modifying the charter to include something like this.
Again, we got 5 minutes, so let's see if we can drain the queue. Britta, you're up.
So I'm recalling back to some of the early challenges that plagued this draft. I contributed a lot of text back when it was first coming out, and saw a lot of course, the discussion at that time. One of the issues that it faced was that all those folks that Mallory noted who want to define their thing as end-to-end encryption were coming in and saying, but my link layer encryption, that could be end-to-end if you look at ends in just the right way. And I think that's one of the issues that currently plagues it, which comes back to that question before about what is the goal really trying to do here, because it seems quite vague in many ways, and it's hard to recognize in the draft your typical definitions of end-to-end encryption that you might even find at most blog posts today. So in that regard, if we are talking about a sort of general definition, I think we'll see that debate rise again, and it might not belong in this working group because, to David's point, it is a security area definition thing. However, we could address a MLS end-to-end encryption definition, which could make quite a lot of headway towards that very problem. And so then not all of the IPsec folks, for example, are going to say theirs is end-to-end encryption. And it might be worth making a design team that focuses just on what is this end-to-end encryption that we are saying MLS achieves. And that may be a first step also towards having a reference draft that has a clear definition of end-to-end encryption that doesn't need to result to vague hand-waving to keep all the different arguments off our backs.
Mallory, thanks for bringing this up. I think the document would maybe be more useful here if it were a little less normative, a little less focused on kind of drawing a line that says this is E to EE and this is not. I think what would be potentially, thinking through like what would be the most useful flavor of this, and what was coming to my mind is that there are in fact some ambiguities about exactly what people mean by end-to-end encryption in the sense of the various properties you might achieve. Encryption just in terms of encryption without authentication is a pretty common property that things like Signal and WhatsApp typically achieve. And then there's various notions of authentication and metadata resilience. So I think kind of enumerating that taxonomy, more as a kind of a design guide, as you were saying, that there was various design considerations when you're approaching this problem of creating something that you might plausibly call end-to-end. Articulating that as kind of design guides, I think could be a more useful approach. Sorry, I lost my train of thought there. You get to stay up late, or get up early, we get to deal with jet lag here. So yeah, I think that sort of approach could be useful. One of the things I think is interesting about that approach is that all of those things sort of show up, mutatis mutandis in other IETF contexts, right? It's the same sort of, encryption, authentication, metadata resilience you see with something like TLS, PKI, onion routing, say. And so I do think that the broader context of some other IETF things would be useful in putting this whole story together. So in addition to the kind of is this in the charter considerations, I think it's actually probably more useful to frame this in a broader context in the history, the overall evolution of how we thought about security in the IETF, because this is just sort of the modern, most application layer incarnation of this whole set of design patterns.
All right, Rowan, you kind of maybe get the last word.
Hey, so I think that having a definition, a referenceable definition would be useful. I think it's topical, particularly when there folks are like, yeah, we can do end. It's fine for people to do end-to-end encryption as long as we get to go and insert parties into the, into the groups. But I don't think MLS is the right place to do it. And when I heard Mallory say the word systems, I was like, okay, I mean, we have a working group that's working on a system right now, and it's called Mimi. And I don't think it really completely fits there either, because it's not about interoperability, it's about the definition. So I don't think we should do it here. I think it's going to be a significant distraction, but I'm totally okay with us doing like cross posts and some reviews and like borrowing people and stuff like that. But I don't think this belongs here. Sorry, Paul.
Thanks. Yeah, no, I really like your last words were great about like getting the reviews from this group. I think that is such a great benefit of just presenting this here. And I feel like at the very beginning of this draft, we actually presented in MLS as well. And it didn't find a home here and got punted out again. So yeah, like just want to thank everybody for interfacing with it. I'm happy to keep talking about it in the list as far as that's useful. We can always go to Paul and ask again, where maybe this is.
Okay. All right. Well, thanks for staying up late. I guess the closing words is there is a presentation in Pair G about MLS. So if you have some free time, you can go there and check out the presentation. Let's support the MLS crew. All right. Thank you very much. All right, now it's time to be overfed again. Eating more food? I think the snacks are out. Yeah. Oh, yeah, snacks. Snacks, including like whole chickens and whole chickens. It's great. Well moved. All right, well, let's talk for 2 seconds. August is
I've worked in a project the last couple of months, and you also worked on that. They work on yeah, you catch.